Yeah. So in this session, we'll be talking about Python's recursive functions. Recursion. So what is recursion? See, recursion is an act of calling a function by itself. Okay. So normally a function calls other functions, and through other functions they get the work done. Okay. So for example, from one function or from main function, I can call another function called add or subtract or multiply, whatever it is, and once I get the result, I can use it in my main function. So this is calling one function to another function, from that function to some other function, so it can keep on going like this. But recursion is a concept where a function calls itself. Okay, so how is it possible? So let us achieve that in Python. I'll just get into my Jupyter notebook. Now I'm going to write a simple factorial function. So let me call def. So in Python, every function starts with the keyword called def. Def means definition. Then I am just calling name as my factorial. Okay, my factorial. Fine. Then I'll just give one parenthesis. Then I just say for which number I want to find factorial. So let me call num. So num is the variable, basically which refers to some value, maybe some integer value, for which we'll be finding the factorial. Right? So when you say factorial, so this function, okay, see, when you write a recursive function, there should be some way to come or exit the function, some way to exit the function. Okay, so when you say a function, it returns a value. Of course, this factorial also will return a value, but at one point of time you must come out of that function so that the recursion ends. So whenever we write a recursive function, we must make sure that the recursion ends at some point of time. Okay, without ending, the recursion will keep on going like that. So we need to end somewhere. Okay, so in factorial, if you take, suppose if I say 5 factorial, then okay, 5 factorial nothing but 5 into 4 factorial. Okay, then if you say 4 factorial is nothing but 4 into 3 factorial. Okay, so if you keep on going like this, when you come to 1, it's nothing but 1 factorial is 1. So at that point, when it reaches 1, we must return that 1. In the meantime, on all other cases, we must keep on multiplying the existing value with the factorial minus 1. Suppose if I say n is factorial, so I should return n into my factorial of n minus 1. So let me just put into code now. First, so let me give that termination condition. Termination means at what point this recursive function ends. So I'll just give that if num is equal to 1, return 1. That's it. Return 1. Okay, return 1 means 1 will be returned. Else means in all other cases. Suppose if it is 5, 4, 3 or whatever it is, so you must return. That should be a return statement. Return. Because every point will return some result. Just I'll show you. Num into my factorial of num minus 1. Look at this. Okay, so you see, when I call from my main function, look at, I take my number like this. Num is equal to int of input of enter the integer value. Okay, for which you want to find the factorial. Then I'm going to call my function like this. So when I call now, it returns the result. So I should print it. So print, okay, my factorial of num. That's it. Okay. So you see, when num is given, suppose if I'm giving value of 5, I'm going to enter a value of 5 here. So it calls like this, my factorial of 5. So this is a calling point. So this is a calling point. So it jumps over here and num will be 5. Then it will check whether num is 1. Num is not 1. So it comes to this point. Then this is a return statement where presently num is 5 into my factorial of 4, because num minus 1 is 4. So just assume at this point we will be returning 5 into my factorial of 4. Okay, So you see, now return means, see, for example, as far as this first statement is first calling point itself, is the first invocation at that point, the result will be returned to this point because it returns 5 into my factorial of 4. So this is the calling point right now. Now this is the calling point. See, every calling point should have a result. See, as this calling point should have a result, so we should return a value to this point. That is why we put return here. We put return here. Okay. In the same way, when I call my factorial of 4, that calling point also should have value. That is why we put this return. That is why we put this return statement. Okay. So when I say my factorial of 4, again this function calls itself. Now num is 4. If num is 1, no. Else return. So look at this. Next point will be return. Where will be returned? To this point will be returned. What will be returned? 4 into, so look at this, 4 into my factorial of 3. Fine. Hope it makes sense. Now see, my factorial of 3 goes again back here. Okay, now 3 is, num is 3. Num is 1? No. Else return means, my factorial of 3 has been called. Now what should be returned? 3 into my factorial of 2. So it becomes like this, 3 into my factorial of 2. Fine. Now see, this point also expects a result. That is why we put this return statement. Okay. So this point, it becomes 2 into, look at, I'll just make 2 into my factorial of 1. Fine. Now num is 1. So because the function calls itself, if num is 1, return 1. So is it, look, this point, to this point 1 is returned. Now 2 into 1 is returned to this point. This particular, because see, when you say true return will be called this point. So 2 into 1 is returned here. Then 3 into 2 is returned. 6 is returned here. Then 6 into 4, 24 is returned here. Then 24 into 5, 120 is returned to this point. Look at this point. We print 120. That's it. Okay. So just run my program. Look at this. I'll just say 5, 120. Okay. Again, I'll call 4. Look at this, 24. Fine. So if I say 6, I'll get 720. Fine. So this is how, okay, we implement factorial using recursion. So you see, it calls, this is the calling for initial calling point. You may supply with any value, 6 or 5, whatever it is. So then it becomes 6. If the num is 1, it returns 1. Otherwise, what happens? It's going to return 6 into 5 factorial. Then at this point, 5 into 4 factorial. Then at that point, 4 into 3 factorial. So it keeps on, okay, iteratively, not iteratively, basically recursively, it calls my factorial itself, the function itself. Okay. So this is with respect to, my factorial. Let us solve one more problem. I want to find the GCD of two numbers using recursion. Let us solve that. Okay. I'll just go here. Let me just escape B. So this problem will be GCD. So let me call markdown. Okay. GCD of two numbers. Fine. Okay. So first what I want to write the function. So let me call f my GCD. Okay, GCD expects two parameters. So let us call that as x and y. Okay, fine. And then we need to have a divisor. Okay, divisor. So what I'll do, I'll just call it as div, not div. Let me call ds, or let us call z. No problem, z. So x, y are the divisor and dividend, and z will be see the least among these two. For example, if I say 10 and 15. See, how do you find GCD? First, let us come to clear terms. How do you find GCD of two numbers? What you do, you take the lower among these two. Okay, for example, 10 and 15. I want to find the GCD of these two. So what we do, we take lower among these two. Between 10 and 15, 10 is lower. So I start dividing 10 and 15 by the lower number. That means 10. Dividing means, we should put, mod operator. So 10 mod 10 is 0, and 15 mod 10, what is the value? But actually, when the divisor divides both, okay, the x and y, z is a divisor. Okay, if x and y they are both divided by the divisor, then that is the, okay, GCD, greatest common divisor. Okay, so the starting point will be lower among these two, because higher number cannot be the smallest divisor. So between these two, which is the divisor? So so x, y, let us take 10 and 15. So we start dividing 10 and 15 by 10. 10 divides 10, but 15 mod 10 will not be 0. We'll get remainder 5. Then we decrease the divisor by 1. So 9. Okay, then it becomes 8, 7, 6, 5. So when it reaches 5, when it reaches 5, 10 is divisible by 5 and 15 is also divisible by 5. Fine. So there it ends. So when x and y are both are divided by the divisor, then the divisor is the GCD, greatest common divisor. Suppose if you take 10 and 13, okay, because 10 and 13 there is no common divisor, so 1 will be the GCD. That's it. Okay. So how do you apply using program? So what I'll do this way. First we have to take I'll start from the main function. Okay, that's just, I'll say pass. Then I'll just say x and y. So let me call directly give value. Later on we can change it. Okay. So what I'll do, I'll just x equal to 10, y is equal to 15. Then I'm going to call print, okay, GCD, my GCD of x comma y comma I'll give the least between these two, 10 I'll give. So let us call it z is equal to 10. Of course we can write a function to find the least among these two. Okay, that's also possible, but I don't want to do that right now. So just pass the least among these two. Okay, how do you find it? If x is less than y, then z will be x. So I think I can do that way. See, if x is less than y, okay, then z will be x. Okay, z will be x. Else, okay, z will be y. That's it. So see, between 10 and 15, see, x is 10, y is 15. 10 is less than 15, then z is divisor is 10. Suppose if I had given this way 15 and 10, then if x is less than no, so y will be the divisor. So that means y will be 10. In this case, y will be the divisor. That is assigned to z. So we are calling like this: my GCD of 10, 15, 10 in this case, or whatever it is. It doesn't matter. 15, 10. Okay, then you will get 15, x will be 15, y will be 10, and z will be 10. Fine. Okay, now what do? If, okay, x mod z is equal to 0 and y mod z is equal to 0, return z, because z is the divisor. See, for example, you see, x is 15 here and y is 10 here and z is 10. So x is, look at this, 15. Okay, 15 mod 10 will be 0? No. 5 is the remainder. Okay, so the moment it becomes false, short circuit, that's it. It does not go here. Because x is 15, y is 10. Then, so it does not go here. So else what we do? We are going to call my GCD with the same x comma y parameter, but z reduced by 1. Look at this. Reduced by 1. So z becomes 9. Fine. Again it calls. So I had to put return here. Sorry, return. Okay, 9. So when it becomes 9, 15, 10, 9. Does not divide naturally. So it becomes 8. Then it becomes 5. So 15, 10, 5. See, at this point, then we are going to just closing in. We are closing in. Okay, that means x is 15, y is 10, and z has become 5 now. Because from 6 I have reduced it to 5. Okay, so when it becomes 5, look at this. 15 mod 5 is equal to 0, yes. And 10 mod 5 is equal to 0, yes. Return z. That means 5 is the answer. Okay, so look at this. We'll just print it. I'll just run it now. 5 is the answer. Okay, suppose if I make it to whatever it is, 28 and 14, whatever it is. Okay, so 14, because between 28 and 14, 14 is the GCD. Okay, fine, greatest common divisor. Suppose if I say, okay, 33 and 11, whatever it is, 11 is the divisor. Okay, suppose if I say 30 and I think 18, 6 is the, look at this, 6 is the GCD. GCD is 6. Fine. So I can do this way. What I can just say, okay, F GCD of X and Y. Okay, is okay. Let us call this way. My GCD, I put this way. Okay, my GCD of X comma Y. So let us try this way. Yeah, GCD of 30 and 18 is, so look at this, formatted output GCD of, then you put the variable X inside floor bracket, Y also inside floor bracket, then this function call itself within floor bracket. Look at this, my GCD of X comma Y, because when you say my GCD, it itself is an object. So you see, any object should be within floor bracket, that's it. It doesn't matter whether it's a single variable or a function. See, function is also an object. As far as Python is concerned, even a function is an object. So any object should be within floor bracket. Okay. So here I'll change it. I'll make it 150. GCD of 150 is 50. That's it. Okay. If you want, you can give it dynamically. Give two input statement here. X and Y. Look at this. X equal to, make it dynamic, int, enter the X value, enter the first integer. Okay, then I'll just say input, okay, same way I'll just say enter the second integer, fine, second integer. Okay, so now it becomes dynamic. So I'll just say enter the first one, I'll just say 189. Okay, second integer 123. Yeah, 3 is the GCD of 189 and 123. Okay, again I run it. Look at this. So 126, some number, 167. Okay, GCD of 126 and 127 is 1. Okay, so now we have learned how to write, okay, GCD, not only finding GCD of two numbers, but also how do you apply using a recursion. So when it's a recursion, GCD calls itself. Look at this. Return my GCD, okay, with X comma Y, then Z minus 1. So the value gets reduced. We start from the lower among these two. We keep reducing it until both of the numbers X and Y are divided by Z, or 1 reaches. Because when there is no common divisor between X and Y, 1 is the common divisor. That's it. Okay. Hope this session was useful. We'll meet in the next discussion with some other exciting example. Thank you.